Our session today, we'll look at random variables. So a random variable is simply a numeric quantity whose value depends on the outcome of a random experiment. It is simply a function that assigns a real number to the possibility, which is a probability. So if you're tossing a coin, for instance, X can be 1, 0 can be heads. So the number of entries you're going to have will be chance of having a 0 head, chance of having 1 head or 2 heads. So these are the outcomes. So we have different types of random variables. There's what we call the discrete random variable, which takes specific countable values. And we have continuous random variable, which takes on any value within the range. So with this, we just need to understand how to calculate the mean, the variance, and the standard deviation. So you can have variables 1, 2, 3, 4, and maybe 5. Okay, let's start 4. And the probability that we have in here should add up to 1. So maybe we have a probability that 1 coin out of the 4 sessions you're going to have maybe 1, we have 0.2, maybe 2, we have 0.1, maybe 3, we have 0.2, and 4, we have 0.5. The total of the probabilities must add up to what? 1. So to find the mean, the formula for the mean is simply summation of x over simply xpx. So we multiply this column, the x times the probability. So this is simplest to find. So x times the probability of x. What we want to find is the mean, which is also called the expectation. 1 times 0.2 is 0.2. 2 times 0.2 is 0.2. 3 times 0.2 is 0.6. And 4 times 0.5 is 2.0. So when we add up all this, what we get is called the mean or expected value. So here we're going to get 10, 0 carry 1. Here we're going to get a 3. So we can use this table. Okay, the expected value, summation of x, px, is simply given by what? Okay, each individual value of x, so 0.1 times 0.2, we don't want to use the table, same thing, plus 2 times 0.1, plus 3 times 0.2, plus 4 times 0.5. So collectively, what are we going to get? A 3. So our mean, or expected value, sometimes we use actual letter E and an X, or you use mu like this, or you use summation of x, px. All this is meaning one thing. The expected value is 3. Then to find our variance, we first square the values of x. So here, we're going to square these values here. What is 1 squared? It's 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. Then you apply this by the probabilities. 1 times the probability. Okay, so this will be x squared px. So 1 times 0.2, get a 0.2. 4 times 0.1 is 0.4. 9 times 0.2 is 1.8. And 16 times 0.5 is what? 8.0. So we add here 2 plus 4, 6. 6 plus 8, 14. And here we have 10. 10.4. So the variance that we use, please, is different from the one in statistics. So it is simply, so this was summation of what? xpx. And this was summation of what? X squared px. So the answer of the variance is simply the difference between x squared px minus the mean that we calculated squared. So minus the mean to the power 2. So 10.4 minus what? 3 squared. And 3 squared is 9. So we're going to get 1.4. That is our variance. 1.4. Standard deviation is when we square root the variance. So what is the square root of the variance there? The square root of 1.4. What do we get? You have a calculator nearby. This calculator giving you
1.18.
1.18.
Yes, 1.18.
Then we go to the other parameters, probability. The grammar, you should have passed your English at least at this point. So if you say greater than 2, x is greater than 2, which values are greater than 2 here? Probability of 3 and probability of x equal to 4. So x is greater than 3, we're looking at probability x is equal to 3. That's probability of x is equal to 4. And what is the probability of x is equal to 3? So find the probability that x is more than 3, more than 2. So starting from 3 and 4. So that's 0 0.2 plus 0 point what? 5. What do we get there? 0 0.7. Okay. Suppose you're being asked to find the probability that x is at most 3. At most 3 means what? Most 3 means what? 3 and below. At least 3 means what? 3 and above. So at most 3 means should be greater or less than 3. So which probabilities are we looking at? Probability of 3 itself plus probability of 2 plus probability of what? 1. So at most 3 means 3 going down. What is the probability of 3? 0 0.2. Probability of 2, 0 0.1. The probability of 1, 0 0.2. What do we get? 0 0.5. Okay, these principles are going to be important in the other probabilities also, so you need to know them. What if I say probability at least 3? What does at least 3 mean?
You see, 3 and above.
3 and above, yeah. Probability of 3 plus probability of 4, right?
Yes.
So what is the probability of 3? 0 0.2. And probability of 4, 0 0.5. So ultimately we get 0 0.7. That is at least what? 3. Is that clear? Anyone behind? Please speak now or forever hold your peace. Okay. Anyone behind? We're together?
We are.
Right. So now let's get to another part. So before I go there now, let's reflect on the question that we had. So in here, we've been given our number of customers and the probabilities. So how do we calculate? How do we label this? Okay, you can sketch this using straight lines. Okay. We have what? Probability can have 0 here, 0.1, 0.05, 0.1, 0.15, 0.2, 0.25, 0.3. And here we have 10, 11, 12, 13, 14, 15. So these are 10,
Oh,
11,
okay.
12, 13, 14, 15. So what's the probability? 10 against 0.05? Put it here. 11 against 0.10? Put it here. 12 against 0.15? Put it there. 13 against 0.25? There. 14 against 0.20? Put it there. 15 against 0.10? Put it there. Okay? So draw a frequency polygon. So here, join that. Okay. If they say draw a line graph, just draw lines like that. Line graph looks like. Okay. Are we together? Justify that the shape of the graph represents what? A normal distribution. Yes. Looks normal. See there. And calculate the expected number of customers. How do we calculate the expected number of customers? Summation of x is equal to what? 10 times what? 0.05 plus 11 times plus 11 times what? 0.10 plus 12 against 0. What? 15. Until the last figure, 16 against 0.10. Are we following? Or not find the mean? Together and finding the mean. So we're just multiplying each of these ones with what is available there. So you calculate answers, you will get. Then we've calculated how to find the mean. You can use a table or you can use a calculation that's been given. So you get your 13.3 as our mean or the expectation, which is here. 13.3. So the variance can be calculated, although we're not asked, can be calculated by xpx minus the mean. So we talked about the two types of probability distribution, discrete and continuous. The discrete encompasses the binomial, the Poisson, geometric, and the continuous is where the normal distribution, the exponential, and the uniform distribution fall under. Okay, so anyone behind at that point before we proceed? Okay, so now we go to question number 1, which is under the normal distribution. Question number 1 is here. We have been given a frequency distribution there. Frequencies, we are asked to calculate our. So I was teaching about the normal distribution just this week. Those of you who just joined, I'll teach that again. But in the event that you are in the paid app, just get the videos and go through so that it's easy for you to understand when I meet you. I may not even need to meet you because the class was very elaborate. Okay? Unless you just want me to take you through again. So this is what you're submitting at your school, whether you're doing it alone or not. So we're given the following. So we are told that the equation follows a normal distribution. This is a Gaussian formula. And we're given the frequency of customers against the probability of buying. Explain the graph in terms of the distribution. How do you explain the graph in terms of the distribution? So the graph should be a bar or frequency polygon with frequencies that are on the x-axis, that's probability of x, and on the y. So the bars here are centered on the values 1, 2, up to 10. The heights are corresponding to those. So we can draw this one to show the distribution at the peaks. Okay, so we submitted this paper or question. I'm sure we do remember that the frequency followed the normal distribution in your paper. So we had what? A situation where we had 1, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here the probabilities. We have 1, 0.2, 0.3, 0.4, 0.5. So 1 against 0.02, somewhere here. 2 against 0.04, somewhere here. 4 against 0.08, 5 or 8 against 6 against 0.12, 8 against 0.16. Okay, 7 against 10 against 0.2. I have 7 against what? 0.14. 5 against 0.1. 1 against 0.002. Draw this basically to look like a normal distribution. Like a normal distribution. You draw this properly. Okay. What is a normal distribution? So when the standard deviation is given normal distribution, the area under graph on the axis is between negative infinite and z 2.5. So given the standard deviation, find the area under graph. Okay, so if we're given those parameters, given negative infinite to z is equal to 2.5, what is the area under graph? So this is what we were looking at yesterday. So based on the question, what are we given in there? Our We need to be given mean of the data. Okay. We want area between negative infinite and 2.5. This is given directly by the normal distribution table. So the area under graph, 2 point. Okay, so let's do this. How do we find the area under graph between negative infinite and 2.5? How do we find the area under graph between so we need to illustrate this. We know that infinite negative comes from the negative left. So the area under graph here we're looking at is simply here. This is negative infinite here. And we have positive what? 2.5. So the area under graph between these two. Okay. Who remembers? Is the shading big or small? Is the shading big or small?
It's big.
It's big. So what are we going to do? We're going to redirect or we're going to subtract.
We subtract from 1.
So why are we subtracting from 1? The area under graph is big. That's what that way in my class. The area under graph is what? It's big. What do we do?
We leave it the way it is. At the moment.
Yes, we leave it the way it is, okay? Because those readings that we have in the cumulative table are coming from negative infinite. So when we check in the table, I sent you the tables yesterday. We check under 2.5, the reading. What do you find? 0.9938. The reading under graph here is 0.9938. Okay. So I hope we remember how to read the tables from the statistical tables. 0.9938. That is the reading from the statistical table. Okay, let me just beam my statistical table here. Do we remember how the reading is done? On the statistical tables, we start by reading what is on the left side, 2.5, and if we have any number at the far end, we read it from the top. Okay, so that is how we read our Z tables. Okay, can't see my tables yet. So whilst I'm looking for the table, let's try second question 1.4. These are very easy questions with easy marks. 1.4. Suppose you have a population parameter that is approximately normally distributed with the mean 10 and standard deviation 2.5. What is the probability that a measurement taken at random from the population will have equal to or greater than 15? Let's use ISA. What's the first step?
We illustrate.
We illustrate, okay? So what are we illustrating? What is in the middle?
The 10.
The 10, which is a mean, okay? And what is our standard deviation?
2.5.
2.5. And what is the question asking for?
To find the probability that a measurement taken at random from the population will have a value equal or is equal to or greater than 15
Where is 15? On the right side or on the left side of 10?
on the right side.
Where are we shading? On the left or on the right?
On the right,
Right, because the term greater means what?
15.
Right. If it was less, so we said RG, right, is greater, LL, left is less than. So we're going to shade on this area. But before we shade on this area, we need to do what? We have illustrated, we have shaded. What are we doing now? Standardizing. What is the
Standardize.
standard figure for 10? 0. What is the standard for 15? We compute. How do we standardize 15? What's the formula for standardization?
It's x minus mean divided by standard deviation.
Okay. Do you remember this?
Yes.
So can you standardize that for me?
So x will be 10. Oh, sorry. X will be 15.
X will be 15.
Then mean will be 10.
Then the remaining will be what? 10. Okay. So
Mhm.
the mu will be 10. So what are we getting in the, what are we getting there?
So 5 divided by 2.5.
Okay. 5 divided by 2.5. What are we getting? Okay.
5 divided by 2.5. It's 2.
It's what? 2. Okay. So we have what? X is our x is 15 minus 10, which is 5 over 2.5, which is 2. And what is the reading for 2? We've memorized it by now. What is the reading for 2.0?
2 point.
Mm-hmm.
So
0 point what?
2.33.
We found 2. What's the probability of 2?
1.
0 point what?
Probability of 2.
9, 7, 7 what? 2.
2.
You don't remember this?
Unless we check the Z score.
Okay, tell me. Here's the Z-score. Show me the reading for 2.
For 2. 0.9772.
0.9772 here. Correct. Okay. After what we looked at, this is just porridge, isn't it? So this is the area from here to here. So how do we get the reading from there? Probability of x is greater than 15 is the same as probability of what? Z is greater than what? Greater than 2. So we're going to have 1 minus what? 0.9772.
770.
Who remembers the answer even without calculating?
0.228.
Yes, 0228. Ah, now we're putting your memory to use. So now, Papa, this question is coming. Don't say I didn't tell you. Terrible exactness. So practice this. We're making the answer sheet. We're making the marking key, right? I'm almost done with the pamphlet. I've just done the way he might twist a few things, but we are just relying on the materials that he produced. Normal distribution is not going to be complicated as this. In fact, this paper is going to be simpler than what the other guys have been writing. Where I'm a little bit worried is on hypothesis testing, because the new people have not understood. So please, those of you who are still joining, listen to the video, spend your time. Because tomorrow, I'm not meeting you. I think on Sunday, that's when I'm meeting you. So take time to listen to all my videos. All right.